Hello everyone. In today's video, we're going to answer a word problem related to modeling and optimization using calculus concepts. So here's the problem. A rectangular closed tank is to have a square base and total capacity of 400 cubic centimeters. Let's answer the following questions. Find a model or function that will optimize the surface area of the rectangular closed tank and express the answer in terms of x. After that, find the value of x that will give the minimum surface area. And lastly, calculate the minimum surface area. So let's start with letter A. So we want to know what is the function to be found, to be identified, and that is the surface area. So remember that the surface area of the closed rectangular tank is simply the area of all the faces. That includes the two bases here, one on top and one below. That's why it's very important to know that the tank is closed because we're going to add the area of the two bases. So let's say we have the surface area here, and let's represent that as a variable a. So we have the area of the two bases plus the area of the four faces, the one in front, the one on the right, the one on the left, and the one at the back. Okay, so assuming this would be a variable h, so the area of one of the faces, actually the area of all the faces, is given by x multiplied to the height. However, there are four of them, so we have so that would be the four area of four. Let's just call them faces, and the other two up and down, the top at the bottom, let's call them bases. So representing them by their respective variables, so the area of the two bases would be 1 is x squared, and since there are two of them, so you have 2x squared. The area of one of the faces is x times h, and since there are four of them, we have 4x each. However, our job here for letter A is to express the answer in terms of the variable x. It would be nice to use this information wherein the volume of, or the total capacity, or the maximum volume it can hold is 400 cubic centimeters. So using the formula for the volume, that's the area of the base, which is in this case x squared, multiplied to the corresponding height, which is h. So in this equation, the volume is 400 cubic centimeters. In solving for the variable x, h, in order for us to replace h there in terms of x, we can say that h is given by 400 divided by x squared. So going back to our function, and maybe right now we can express it in terms of a of x, or write it in terms of a of x to denote that the given is expressed in terms of the variable x. We have 2x squared plus 4 times x multiplied to h, which is now equal to 400 over x squared. Simplifying further, a of x equals 2x squared plus 1,600 all over x. That is the function that will optimize the surface area of the rectangular closed tank. Now let's proceed to letter B. Find the value of x that will give the minimum surface area. We already have the function from A. Now we want to know how to determine the value of x that will give the minimum. So remember that to determine the value of x that will give the extreme value, we don't know yet if it is a maximum or minimum, but let's just say the extreme value. It could be a maximum value. It could be the minimum value. Okay, but we know that the value of x that will give such extreme value will be found or located at the critical points, wherein its x coordinate or their x coordinates are called the critical numbers. So how do we find the critical numbers? So to find the critical numbers, all we have to do is to let the derivative of the function that we identified equal to 0 and solve for x. Okay, such that, again, a of x is 0 or does not exist. All right, that's a definition of the critical numbers. So how do we do this now? So first, obviously, we have to solve for the derivative. So it would be nice to rewrite a of x into this form so that it would be easy for us to get the derivative. So getting the derivative, we have 4x minus 1600 times x raised to negative 2, or basically 4x minus 1600 all over x squared. So letting this equal to 0, okay, we have the critical numbers. Number 1, the critical numbers occur when it is equal to 0, the derivative. So if we move it to the left, we can get 1600 all over x squared equals 4x, which implies that 4x cubed is equal to 1600, or x cubed is equal to 400, or finally, therefore, x is equal to the cube root of 400, or approximately, in your calculator, you will get 7.3681. Okay, the other critical number would be when the derivative does not exist. The value of x where the derivative does not exist. And remember that a of x does not exist if in this given, the denominator, the variable in the denominator is 0. Because that's gonna make the given undefined. So therefore, x is also equal to 0. That's a critical number. However, remember that x represents the base. So it's a length. That means it can't be a value of the variable x. So we have to focus on cube root of 400 or 7.3681. The only question is, upon substituting that value to the function a of x from letter a, can we get a minimum value? So for us to know that, we have to use one of the two tests, the first derivative test or the second derivative test. In this example, we're going to use second derivative test. Wherein, according to the second derivative test, if the second derivative of the function is evaluated at the critical number, which is in this case cube root of 400, and the answer happens to be positive, then we can say that the original function a of x evaluated at the critical number will give you the minimum value. That's what we want because we're looking for the minimum surface area. So we have to prove whether the value of the second derivative evaluated at the critical number is positive. So that means we need to know what the second derivative is. So we're going to use this one. Okay, again, to perform the derivative, we simply have to rewrite it again to make it easy for us to get the derivative of the first derivative into this form. So which means the second derivative would be 4 minus negative times 2 times negative 1600, which is plus 3200x raised to negative 3. So finally, we have the second derivative given by 4 plus 3200 all over x cubed. And we already know that for all values of x positive, for all x that's positive, this expression here will always be positive. Added to 4, that's going to be positive. So that means, even without the use of the calculator, we are sure that the second derivative evaluated at the cube root of 400 will give us a positive answer, which implies that a of the cube root of 400 is a minimum value. Therefore, the answer to the question, find the value of x, that's going to give us the minimum surface area. The answer is 7.3681 or the cube root of 400. Now, to proceed to the last question, calculate the minimum surface area. So all we have to do is just evaluate a of x at x equals cube root of 400 because we are now sure that that's the value that's going to give you the minimum value of a of x. A of x represents the surface area. Therefore, a evaluated at the cube root of 400 will give you the minimum surface area. In substituting that to the given function, so let's go back to that function first. Remember that a of x is given by 2x squared from part A plus 1600 divided by x. Evaluating that function at the cube root of 400, you have 2 times, or you can use your calculator here, you will get the answer approximately 325.7301 square centimeters. Thank you for listening.